gives us 1 nitrogen to every 2 oxygen, meaning our empirical formula is NO2. Right there. Now for number 23, we are using our compound from question 21, which question 21's compound is PBr5. Okay. Now we know that the molecular mass of this compound is 431 grams per mole. So where are we going to start? Well, where we need to start is right here. We have our compound. So let's find the molar mass of this compound. So phosphorus, it has a molar mass of 31 grams per mole. Bromine, molar mass of 80 grams per mole. So your equation, you can see we have one phosphate. Okay, excuse me. We have one phosphate, so that is 31 plus, well, we have 5 bromines, so 31 plus 80 times 5. And that is going to give us 431 grams per mole. Well, we have a molar mass of our empirical compound, and we have the molar mass of our molecular. So, what are we going to do? We're going to take the molecular formula's mass, divide it by our empirical formula's mass. Any number divided by itself is going to be 1, which means this 1 is going to be multiplied into our compound, but that's quite simple. PBr5 times 1 is going to be 1 phosphate. So our empirical and molecular formula for this equation are the exact same. For number 24, for question 22, well, we know our compound is NO2, and the molar mass we are given is 92 grams per mole. Alright, so we already have our molecular mass, and the molar mass of that is 92. Now let's go ahead and find the molar mass for our empirical formula. Nitrogen is 14 grams per mole. Oxygen is 16 grams per mole. Don't forget, we have 2 oxygen, so 16 times 2 plus 14 gives us an empirical formula molar mass of 46 grams per mole. Alright, so now the molecular formula's mass is 92 grams per mole. Our empirical formula's molar mass is 46 grams per mole. We divide 92 by 46. It's going to give us 2. What we do with this 2 is we're going to multiply it 2 times our empirical formula, NO2, which means I'm going to now have 2 times 1 is 2 nitrogen, 2 times 2 is 4, so our molecular formula is N2O4. Okay, 25. We have naphthalene is a carbon and hydrogen containing compound often used in mothballs, right? So this is what you stick underneath your beds. Okay, the empirical formula for this is C5H4. And the molecular mass, okay, I know it says molar mass, but the molar mass of our molecular formula is 128.16 grams per mole. So we have some information. What do we do with it? Well, we need to find the molecular mass, or the molecular formula. So let's find it. Carbon is 12 grams per mole. Right, that's its molar mass. Hydrogen's molar mass, 1 gram per mole. But remember, we have 5 carbon and 4 hydrogen. So 12 times 5 plus 4 times 1, and that is going to give us 64 grams per mole. All right, so we have our empirical formula. We have the molar mass for that empirical formula. We have the molar mass for our molecular formula. Let's divide those bad boys. So 128.16 grams per mole. That's our molecular formula divided by our empirical formula molar mass, which is 64 grams per mole. That division should end up giving you somewhere around 2. Okay, so our final results should be C10H8, right? We just multiplied this 2 into our current compound. 5 times 2 and 4 times 2 gives us C10H8. Now here is an entire equation put together. Number 26. A compound with the following composition has a molar mass. So let's just write down the molecular formula. Molar mass is 60.1 grams per mole. Okay, so let's leave that. We don't need that information now. Now, here's what we're doing. Carbon equals 39.97%. Hydrogen makes up 13, well, that's a weird equal sign, 13.41% of our compound. And nitrogen makes up 6.62% of our compound. Go back to what we were doing before, 39.97 grams. Hydrogen is 13.41 grams, and nitrogen 46.62 grams. Divided by their molar masses, we know hydrogen's is 1 gram per mole. Carbon is 12 grams per mole. And nitrogen is 14 grams per mole. Alright, so we're getting to our moles. We got our grams out of the way. Let's get over there. Carbon gives us 3.33 moles. Hydrogen gives us 13.41 moles. And nitrogen gives us 3.33 moles. Lucky for us, we're tied for first place in the lowest molar count. So 3.33 divided by 3.33 divided by 3.33. And we know we have 1 carbon. We know we have 1 nitrogen. Just get the easy division out of the way. Now hydrogen is going to end up being 4. So, our empirical formula. That ends up being CH4N. Alright, so we have our empirical formula. Now, what do we need to do? Well, we're looking for, alright, once again up here, up in the top right, the molar mass of our molecular formula. So we need to find the molar mass of our empirical formula. Well, you should see already, carbon, 12 grams, hydrogen is 1 gram, and nitrogen is 14. So let's set this up in an equation to get our molar mass. Well, we only have one carbon in this compound, so 12 plus hydrogen. Well, hydrogen is 1 times 4 plus nitrogen is 14. And that is going to give us a molar mass for our empirical formula of 30 grams per mole. So empirical formula molar mass right there. Okay, now what do we do now? Well, we need to divide our molar mass, 60.1 grams per mole for our molecular formula, and our 30 grams per mole for our empirical formula, and we will get 2. From this 2, now we're going to multiply that 2 into our empirical formula to get our molecular formula, which means carbon, hydrogen, nitrogen equals 8 and 2, and that, my friends, is your molecular formula for this equation. Alright, onward to molarity. You can see up top I went and gave you the molarity equation. So molarity is essentially moles divided by liters. Alright, so I can give you a number of combinations, have you convert between moles and grams, grams to moles, milliliters to liters. I can even give you milliliters and molarity and have you find the number of moles. Alright, and we'll practice those. So take a look at 27. We have 0.5 moles of sodium chloride, and it is dissolved to make 0.05 liters of solution. What is the molarity? Okay, well, quite simple. We want to know molarity. We have 0.5 moles. How many liters do we have? Well, we have 0.05 liters. Okay, that's going to give us a molarity of 10. For 28, we have 0.5 grams of NaCl, and it's dissolved once again into 0.05 liters. Well, notice this is moles per liter. We have liters, we have grams in this bad boy, so we need to change grams to moles. How do we do that? Well, we need to first find the molar mass of NaCl, and that is going to give us 58 grams per mole. I found that by finding the molar mass. Sodium is 23 grams, so up here 23 grams plus chlorine is 35 grams per mole, and that gives us 58, which you see down below. So once we're done there, we can now convert 0.5 grams of NaCl to moles. 1 mole is 58 grams.